65 kilometers away, a Siberian trader's shirt caught fire. Then the shock wave threw him across his own porch. The forest in front of him was already on its side. It was the morning of June 30th, 1908, at the Vanavara trading post, on the bank of the Podkamennaya Tunguska River in central Siberia. The man on the porch saw no impact. He saw the sky split. This is the Tunguska event, the largest object to strike the Earth's atmosphere in recorded history. Over the next 12 minutes, we're going to look at 3 questions. What actually happened on the morning of June 30th, 1908, and why did seismographs in Irkutsk and barographs in Britain register it before anyone in the Russian capital even knew it had happened? Why the first scientists to reach the site, 19 years later, found more than 2,000 square kilometers of flattened forest, and no crater at all. And what kind of object can do that to a forest and leave no trace of itself behind? The third question is still not fully closed. We will return to it at the end. At roughly 17 minutes past 7 in the morning, local time, on June 30th, 1908, the sky above the Podkamennaya Tunguska River basin tore open. The hypocenter, the point on the ground directly beneath the explosion, sat at 60 degrees, 54 minutes north, 101 degrees, 54 minutes east. There was no town there. There were reindeer herders. There was forest. 65 kilometers south, at the Vanavara trading post, a man named Semyon Simonov was sitting on the porch of his house. According to the account collected from him in the 1920s, he saw the sky to the north split in two. Fire appeared above the line of the forest. He felt heat strong enough that he later described it as if his shirt were on fire. The exact phrasing varies between translations of the original interview. Surviving accounts agree on the heat and the throw, but the wording shifts between versions. Then the shock wave reached him. He was thrown several meters from where he sat. Windows shattered for hundreds of kilometers in every direction. To understand what Simonov was describing, heat first, then a wave that knocked him down, you have to remember the geometry. Light travels faster than sound, and a thermal pulse from a high-altitude explosion arrives almost instantly. The pressure wave follows seconds later. The forest in front of him was already flat by the time the noise reached the porch. Closer to the center, the Evenki people, reindeer herders whose hunting cabins and grazing land sat directly beneath the airburst, were the ones who lost the most. A man named Chuchan of the Shanyadra tribe gave one of the principal indigenous accounts. He described the second sun, a light so bright it hurt his eyes. He described repeated thunder. He described trees falling, in his own phrase, like grass. He was knocked to the ground again and again by successive waves of wind. His was not a poetic account. It was a literal description of an airburst, given by a man who had stood inside one and survived. Now, across the rest of the world, instruments were beginning to register what no human eye had seen. In Irkutsk, far to the south, seismographs picked up the shock. Stations across Eurasia recorded the wave at intensities equivalent in places to a magnitude 5.0 on the Richter scale. The atmospheric pressure wave kept traveling. Barographs registered it in Germany, in Denmark, in Croatia, in the United Kingdom, in Batavia, in the Dutch East Indies, and in Washington, D.C. Then the sky began to glow. For several nights after the explosion, observers across Asia and Europe reported skies bright enough to read by. In Sweden, photographers successfully exposed plates outdoors at midnight without flash. In Scotland, the same. In London, people reported reading newspapers in the open air at midnight. The Smithsonian Astrophysical Observatory, working from Mount Wilson, documented a months-long drop in atmospheric transparency consistent with roughly 1 million tons of dust suspended in the stratosphere. On July 2nd, 1908, the Siberian newspaper Siberia printed one of the first written eyewitness summaries, describing a bluish-white cylinder descending earthward, loud knocking, and black smoke. The article was read in Tomsk and Irkutsk. It was not, at the time, read in St. Petersburg. By morning, Every barograph station from Washington to Batavia had recorded the wave. Nobody yet knew where it had come from. The empty center of the explosion would not be reached for another 19 years. The man who finally reached the center was a Soviet mineralogist named Leonid Kulik. Kulik was born in 1883 in Dorpat, modern Tartu, in Estonia. He worked for the Academy of Sciences, and his specialty was meteoritics, the study of the rocks that fall from the sky. By the early 1920s, the surviving Siberian article, the seismograph traces, and the indigenous oral accounts had reached him. He believed something enormous had hit the ground in central Siberia, and he believed there had to be a crater. In 1921, he organized an initial reconnaissance of the Podkamennaya Tunguska Basin. He did not reach the impact zone on that trip. The terrain, taiga, rivers, swamp, defeated the expedition before it got there. He came back in 1927. This is where the case turns. Kulik expected an iron-meteorite crater. He expected a hole in the ground, with fragments around it that he could carry back to Leningrad and put under a microscope. What he actually found, when he reached the center of the felled forest, was something nobody had been prepared for. There was no crater. There were no fragments. At the center, a zone roughly 8 kilometers across, the trees were still standing. They had been stripped of their branches and badly scorched, but they were upright. Beyond that central zone, in every direction, lay the radial pattern that has since defined Tunguska in the public imagination. An enormous starburst of fallen trunks, all of them lying with their roots pointing inward toward a single empty point in the air. Kulik later wrote that he circled the region where the trees had been felled and became convinced that they were all turned with their roots to the center. He found no crater. He found no metal. He found no stone. He went back. Through the late 1920s and into the 1930s, he led further expeditions. He drained one of the small bog pits at the center, hoping it might be a buried impact pit. It was not. It was a bog. In 1938, he organized an aerial photographic survey of the level forest. The survey covered roughly 250 square kilometers, producing 1,500 photographic negatives, each 18 centimeters on a side. Those negatives gave the world its first overhead view of the radial tree fall pattern. The original plates were ordered destroyed in 1975 by the Soviet meteoriticist Yevgeny Krinov. Positive prints from the 1938 survey survive today in the city of Tomsk. From this point, Kulik's case was no longer a search for fragments. It was a search for an explanation that did not require fragments. He never finished it. When Germany invaded the Soviet Union in 1941, Kulik volunteered for a people's militia unit. He was captured during the German advance. On April 24, 1942, the exact date is given as 14 or April 24th in different records. In a German prisoner of war camp at Spazdemensk in Kaluga Oblast, he died of typhus. He was 58. He never explained what he had seen. The first plausible answer came 2 years after his death, and it required scientists to accept that the object had never touched the ground. The first plausible answer had actually been published in 1930, while Kulik was still in the field. It just took the rest of the world the better part of a generation to come around to it. In 1930, a British meteorologist named F. J. W. Whipple proposed that the Tunguska body had been a small comet, a loose, dirty snowball of dust and frozen volatiles. A comet entering the atmosphere at tens of thousands of kilometers an hour would heat catastrophically and could vaporize completely in the air. There would be no crater because nothing had reached the ground. There would be no fragments because nothing had survived. By the 1960s, Soviet investigators had largely adopted Whipple's hypothesis. Microscopic silicate and magnetite spheres, identified in soil and tree resin near the hypocenter with high nickel-to-iron ratios consistent with extraterrestrial origin, made the case that something extraterrestrial had passed through. The remaining question was what? In 1978, the Slovak astronomer Lubor Krysak refined the comet hypothesis. He proposed that the Tunguska body had been a fragment of comet Evenki. The date of the explosion, June 30th, 1908, fell at the tail of the peak period of the beta towards meteor shower, which is debris from comet Evenki. The geometry was suggestive. 5 years later, in 1983, the astronomers Zdeněk Šekinina pushed back. Šekinina argued that a shallow trajectory cometary body, made of loose volatile material, will have fragmented and dissipated much higher in the atmosphere, too high to flatten the forest. Whatever broke the sky over Siberia, in his analysis, had to have been denser. He advocated for an asteroidal origin, a small stony body, not a comet. In 2001, a team led by the Italian astronomer Paolo Farinella, with Luigi Fascini and others, published an orbital modeling study that ran the candidate trajectories backward against the known catalog of asteroid and comet orbits. Their conclusion, roughly an 83% probability of asteroidal origin against a roughly 17% probability for a cometary one. This is where the missing crater question got reframed. In 2007 and 2008, a research team led by Luca Gasparini of the University of Bologna proposed that the question of the missing crater might have been wrong from the start. 8 kilometers north-northwest of the hypocenter lay a small lake, Lake Checo, 500 meters long, 300 meters wide, 50 meters deep, bowl-shaped. Gasparini's team reported a magnetic anomaly at its deepest point and a sediment thickness they argued was consistent with a roughly 100-year age. Their proposal, Lake Checo, was a secondary crater, formed by a surviving fragment that had punched through after the airburst. It was a striking idea. It did not survive. In 2017, Russian scientists used radionuclide layers in the lake's varve sediments, fallout from mid-20th century Soviet nuclear weapons tests, to date the bottom of Lake Checo. They counted at least 280 annual layers below the youngest fallout markers. The lake, by their analysis, predated the Tunguska event by centuries. It is not a Tunguska crater. Mainstream modeling today describes Tunguska as a stony asteroid, 50 to 80 meters in diameter, entering the atmosphere at around 55,000 kilometers an hour and detonating in an airburst at an altitude between 10 and 14 kilometers, with a yield in the range of 10 to 30 megatons of TNT equivalent. There's one more thing. The empty crater has, over a century, drawn more than its share of speculative explanations. A 2014 ArXiv paper, for instance, proposed a dark matter ball of bound top quarks tunneling through the Earth, a fringe hypothesis that has not entered mainstream literature, and which is mentioned here only because the missing crater has invited speculation for 100 years. The mainstream debate is narrower than that, and it is still not closed. A 2013 joint U.S.-European analysis was reported as consistent with an iron-meteorite origin, a result that sits in tension with both the 2001 Farinella stony asteroid conclusion and the 2017 rejection of Lake Checo. Modern models give us the size, the speed, and the altitude. They do not tell us, with certainty, whether the thing that broke the Siberian sky on June 30th, 1908 was a comet or stone. Semyon Sinov sat on his porch of Vanavara, 65 kilometers south. He felt the heat before he heard the sound. He saw the sky split before he understood that he was being thrown. The forest in front of him was already flat by the time the noise of the explosion reached the porch where he sat. What survived him is more than is sometimes assumed. The radial tree fall pattern is still visible in the soil and in tree ring records. Kulik's 1938 aerial survey prints are preserved in Tomsk. The seismograph traces from Irkutsk and the barograph traces from Britain, Germany, Denmark, and Washington, D.C. are in archives across 3 continents. The Evenki accounts, Chuchan's second son, the trees falling like grass, were collected and written down in the 1920s, and they remain part of the primary record. What did not survive is also important. The Evenki lost reindeer, hunting cabins, and several hundred square miles of forest they depended on. Up to 3 deaths are mentioned in some surviving Evenki accounts. The figure is uncertain and treated by most historians as unverified. Leonid Kulik never closes case. And the question that hung over Tunguska for nearly a century is still hanging. We do not know with certainty whether the object was a comet or a stony asteroid. The Lake Checo proposal is not accepted. The 2013 iron-meteorite analysis sits in tension with the 2001 stony asteroid result. The comet versus asteroid question is not yet closed. On the rough recurrent statistics, objects in the 50 to 80 meter range are estimated to enter the atmosphere on an infrequent but historically documented interval. The next one is not a question of whether. It is a question of where. It will not, the second time, have the courtesy of empty Siberian forest to land in.